All right, guys, I got this review for test 30, the last one for seniors. So here we go. Parabolas, don't forget the 4p goes opposite the side with the square. So this time 4p is negative 32, which means p is going to be either negative 8 or 8. So vertex is 0, 0, like we did all week. Because the 32 is the y, means it's going to go like the y-axis does, going down 8. So there's a focus down there, down 8. Perhaps going to look like this. The directrix is going to be up 8, like that. So where's the focus? The focus is at 0, negative 8. Where's the directrix? It's at y equals 8. The FD, the focal diameter, is 4p, but you got to make it positive. It's 32. All right. The second one here, going to find what p is again. So 4p, in this case, is negative 5, divided by 4, so p is negative 5/4. The vertex, 0, 0, like all week. This time, the 4p is with the x, it's a negative. The focus is negative 5/4 way, which is like 1 1/4, so it's right there. So the parabola is opening this way. The directrix is 1 1/4 back here. Not very accurate there. The focus then would be negative 5/4 and 0. Your directrix is going to be x equals 5/4. Your focal diameter is going to be 5 because it is 4p. Number 2, now we're back to ellipses. With ellipses, you want your equation to equal 1. So I'm going to divide everything here by 36, make it x squared over 36 plus y squared over 9, because 4 goes into 36 9 times, over 1. Which means my vertex, because the a squared is underneath my x squared, which means you're going to go 6 on your x-axis both ways. And you're going to go up 3 and down 3 on your y-axis. So your actual ellipse is going to look like this. Hopefully yours looks better than mine. Your vertices, remember, on your major axis, so they are plus or minus, they're the 2 6s. Your foci, to find the foci, you're going to go a squared minus b squared. So I'm going 36 minus 9. That's 27, which if you break that down, you get plus or minus 3 on 3. So your foci are also on the major axis, to be plus or minus 3 on 3 and 0. Eccentricity is c over a. So I'm going to go 3 on 3 over 6. The 3 and 6 cancel, so I get square root of 3 over 2. Punch out in your calculator to get a decimal. Let's see, square root 3. I'm getting 0.866 there. Or 0.8661 if you, or no, it'd be 0. And then length of the major axis, how big is the major axis? Well, 6 left and 6 right is 12. The minor axis is up 3, down 3, that's 6. That's all we got. The second one on number 2. Same deal, just divide by 144. I get x squared over 12 plus y squared over 144 equals 1. Your vertices are your major, so I got to go up 12. My graph isn't quite big enough. Oh, 12 down 12, we'll say it's there. I'm going to go right square root of 12. Square root of 12 is like 3 point something, negative 3 point something. So my ellipse is going to look like this. Pretty good for me. Vertices will be at 0 plus or minus 12 because the vertices are at the ends of the major axis. Your foci, again, subtract 144 minus 12 is 132. If you take the square root of 132, you're going to get plus or minus, let's see, 4 goes in there 33 times, so you're getting 2 on 33. And remember, those are in your major, so I'm going 0 and plus or minus 2 on 33. Your eccentricity is c over a, so I'm doing 2 on 33 over 144, which is really square root of 33 divided by 72, which is giving me 0.0798. Pretty small eccentricity because it's so far stretched out. The closer it is to a circle, the higher eccentricity. The closer it is to not being a circle, it is closer to 0. So how long is the major axis? I went up 12, down 12, I went 24. The minor axis, I went right square root of 12 and left square root of 12. Square root of 12, by the way, is 2 on 3. So really it's 4 on 3. I went right 2 on 3 and left 2 on 3. Hope that helps. I went right square root of 12, left square root of 12. That's the square root of 12, so you double it. Let's see what the next problem is. Next slide. All right, number 3. Find an equation for an ellipse that satisfies those conditions. Okay, so use what they give you. That's the key. Use what they give you. Vertices. First of all, they're telling me the vertices are on the x-axis. So I know that the 6 squared goes under 36. What I don't know is what goes underneath the y squared. I know it equals 1, so it's got to find my b squared. That's the key, just b squared. So the foci says is at 4. So remember our equation for the foci, c squared equals a squared minus b squared. So c squared is 4 squared. A squared is in the equation already, it's 36 minus b squared. I can tell by looking at that, it's saying 36 minus something is 16. It's 20, and it's b squared. Remember, I need b squared, not b. Number 4, found an equation for the parabola. Vertex at the origin and satisfies this condition. Focus is 0, 2. If I were you on the parabola question, I would draw a graph, help you see it. It says the vertex is at the origin, which is right here. The focus is up here at 2, which means it has to open up. And so that's a big deal, because if it opens up, that means the 4p is with the I, the square is with the x. And I also know what p is just by looking at that. P is how far is from vertex to focus, which is 2. So 4 times 2 is 8. Y equals x squared. And that's all you got. Number 5, find that limit. Now, it's an absolute value. So it's absolute value. Remember, you got to do 2 things. You got to do limit as z goes to 0 of the positive absolute value. Now, the absolute value of a positive number is just itself. So you say 2z over z, which would be the limit as z goes to 0 of 2, which is just 2. Then you got to do the negative side. So I should have put a positive side there. Limit as z goes to 0 from the negative side. The absolute value of a negative number is the opposite of itself, which would be negative 2z over z. That would cancel into, if you cancel your z's, that would leave you negative 2, which the limit would be negative 2. Now, because those two absolute values are different, it does not exist. That absolute value does not exist right there. All right, number 6, sketch the graph of the function. Make sure you do the correct end behavior, all the things. So let's make that a little bit bigger. So I'm going to factor first. I'm going to take out an x. Let's see, f of x equals, take out the x out. That leaves x squared plus 2x minus 8. Keep going with that. I have x plus 4, x minus 2. So my zeros are going to be a 0, negative 4, and 2. There's no bouncing at all because there's no squares. It was odd and positive when I started, which means it's going down, left, up, right. That's important. So I'm going to put a point at 0, a point at 2, point at negative 4. And again, odd, positive goes down, left, and up, right. So it's going to do something generally like that. So just show me where your zeros are, show what your graph does. We're not going to worry right now about how far up we went or how far down we went. Number 7, graph and all the asymptotes, domain, all the things again, all range, all those kinds of stuff. So first of all, I'm going to factor the numerators, which is 2 times x minus 1 over x plus 1. Okay, here we go. Verbs, whatever makes the bottom 0. X equals negative 1. Horizontal, got the 3 rules. This time the degrees were the same, so it's y equals 2. Now it doesn't say anything about intercepts. However, to graph it, you're going to have to find the x-intercept. X-intercept sort of makes the top 0, which should be 1. The y-intercept, plug in 0 for x, you get negative 2. So I'm going to graph that stuff right there that I've got. The vertical is at negative 1, right there. The horizontal is y equals 2, which is right there. The x-intercept is 1, which tells me a lot. The y-intercept is negative 2, which tells me a lot. What that tells me is my graph is coming down here. It's going to curve up towards the asymptote. But to get the other side, you can either plug a point in like negative 2, or you can like graph it in your calculator and see what it looks like. It's going to be up there though. Now don't forget the last part of the problem. It says find the domain and range. All right, so the domain is going to be all x's, except it skips negative 1. So you can write it this way if you want to, or you can do the interval notation. It's up to you. Range, y, all y, such that y, and y it's going up and down forever, except it skips 2. So there you go. And again, domain's always going to be the same as your verbs. Your range is usually the same as your horizontal. All right, last one here. Suppose you invest $55,000, account that pays 6% per year, compounded monthly. How long will it take it to double? So if you're going to double $55,000, you're going to end up with 110. Well, I showed you a shortcut. You have to do this step if you don't want to, but it's safe. Okay, compounded monthly, thought contingency. So I'm going to 1 plus interest rate over 12. And then it's going to be NT power. So N is 12, T is, we don't know. We need the T, that's what we're looking for. So first of all, divide by 55,000. It's going to be 2 every time. That's why I said I'll just go ahead and write the 2 and I'll write the big numbers up there, but you know, it's whatever you want to do. Work out the parentheses, 1 plus 0.06 divided by 12 I'm getting 1.005 there to the 12t power. And because I need that exponent, because my answer is the exponent, I'm going to do log both sides. I'm going to do natural log 2 is 12t, natural log 1.005. I'm going to divide both sides by the natural log 1.005. So my calculator, I'm punching in natural log 2 divided by natural log 1.005. I'm getting 138.9757. It keeps on going a long way. And I'm going to divide that by 12. So my calculator, I'm just hitting divided by 12. I'm getting 11.6 years for it to double. So that 55,000 turns into 110,000 in 11 and a half years. Not bad. Not bad at all. All right. Hope that helps you. Seniors, I can't believe this is your last review video. Man, I know you're going to miss them terribly. I don't know what you're going to do without them. Oh my gosh. But anyway, it's been awesome. We'll talk about that more Friday. No mushy stuff today. See you, bye.